This example comes out of section 10.1, Sums and Differences of Functions. This example is a little different than the last couple because in this question we're not given the equation of these functions f of x and g of x, we're given their pictures instead. We are asked similar questions in that we're asked to find h of x equals f plus g of x, so the sum of these two functions, and m of x is the difference, f minus g of x. So you would obviously be given very accurate graphs if you're asked to do this on a test where you'd have graph paper, labeled, etc. But let's try it with what we've got. If I'm looking at f plus g, f, for example, at the y-intercept is equal to 3, and at the y-axis, g of x equals 3. So 3 plus 3 is 1, 2, 3, 4, 5, 6, and I'd have a point up here at 0, 7. If I do the same thing for some other points, I can, again, just add the y-coordinates together. When x is 1, for example, and you might find it useful to do a little table to say x, the value of f of x, the value of g of x, which then would allow us to say what is the value of h of x. And I would suggest doing something like that if you're faced with this type of thing in a question. So we already said that at 0, this one was 3, this one was 3, so the sum of them was 6. At 1, f of x looks like it's equal to 5, g of x is equal to 2, so the sum of the two of them will be 7. At 2, this one is at 7, this one is at 1, and you add them up, you get 8. And so we can plot a couple of points here. And you can do a whole bunch more, but you'll find that you are getting a nice straight line type of a graph. So h of x looks something like that. Now, m of x, and maybe just add another column to your chart here, is the difference, f minus g. So 3 minus 3 is 0, 5 minus 2 is 3, 7 minus 1 is 6. Those ones were just as easy to do, especially once you have the table set up. So I've got 0, 0, I've got 1, 3, and I've got 2, 6. So 1, 2, 3. A little bit cluttered. My graph here is getting a little crowded, but I've got m of x looking something like that. Just so you can double check to see if what I've given you is actually true. The functions that I drew originally were actually that f of x is equal to 2x plus 3. That would be another way to do this problem, by the way, is figure out what the equation of that line is. You guys all know how to do slope and y-intercept, hopefully, at this point. So f of x was that, and g of x had a slope of negative 1, but also had a y-intercept of 3. So if I do f minus g of x, f minus g is going to be 2x plus 3 minus negative x plus 3, and you'll end up with 3x plus 0, which is exactly the graph that we've drawn here for what m of x looks like. It goes through 0, 0, has a slope of 3. If I try the f plus g sum function, I'm going to have 2x plus 3 plus negative x plus 3. 2x plus negative x equals x, 3 plus 3 is 6, and so my h of x function is x plus 6, and if you look at that one carefully, it does have a y-intercept of 6 and a slope of 1. So we did do it correctly without the equations. Obviously the equations do make life a little bit easier for that kind of a question.